Welcome to the Earl E. Bakken Medical Devices Center. We were founded here in 2013. We were previously housed in the Shepherd Labs over near the physics building. We're part of the Institute for Engineering and Medicine. We're also part of the College of Science and Engineering as well as the medical school. So being that we're located right in the heart of the medical school gives us access to a number of different medical health professionals. Our facility, the hallway is actually shaped in the likeness of a human spine. This is a repurposed parking garage. I think we use it a lot better than it was previously used. And you'll notice a number of different pillars throughout the center that are actually a byproduct of the fact that this used to be a parking garage. We have almost 9,000 square feet, and you'll see about 10,000 feet of piping in the center. We have an innovation collaborations program where we work extensively with industry. We've worked with over 35 different companies over the last 5 years, and this brings a great model to sustain the center. Furthermore, we host the Design of Medical Devices Conference here on campus. This is the largest device conference in the world, and we're expanding to China and other places overseas as well. We also have an Innovation Fellows program. This is a year-long training program where 6 to 8 mid-career individuals with backgrounds in engineering, law, business, and medicine come together to develop new medical technologies. The first quarter of their year, they go through boot camp to make sure that everybody is on the same page and speaks the same language. The next quarter of the year, they go through clinical immersion. So this is where they actually shadow physicians, watch surgeries. We've had them go up in the helicopters in emergency situations, shadow EMTs, and a number of other things. The goal for this is to collect a large number of unmet needs or ways that we can improve healthcare. They then come back and filter through those needs and determine which projects they'd like to work on for the rest of the year. We've embodied this philosophy also as well in our internship program. We have 25 to 30 undergraduate and graduate students that spend 10 weeks finding a need, fleshing out that need, and then actually developing prototypes and hopefully developing some intellectual property. Between the fellows program and the internship program, we average 25 to 30 invention disclosures each year, which constitutes about 10% of the entire University of Minnesota's intellectual property. So as we enter the center, we'll notice that we have a number of conference rooms, offices, and meeting spaces throughout the center. When designing the center, it was always a challenge to make sure that we had the right breakdown of all of that space. So as we head this way, you'll notice we have our mechanical lab here with a number of anatomical 3D prints that we've done. We have office space for the lab supervisors, the director, our finance directors, and as well as the director of the Innovation Fellows program. Welcome to the Innovation Fellows headquarters here in the center. The Fellows actually have their own wing of the center to do all of their development work over their year-long time here. In this space, they actually have a meeting space where they can hold meetings and discuss their projects. All of the walls are write and erase so that they can write their ideas on the wall and quickly erase them. We keep this door locked with a passcode so that when we have visitors, if there's intellectual property or patent-related materials on the wall, that visitors won't see that. They also have a flat screen TV that they can use to walk through their design work and other aspects. Furthermore, the Fellows offices are actually here in the center as well. And not only is this a great place for them to be, but they're also a great resource for the rest of the center. So when we have a question about various things such as medical anatomy and other things, we have a doctor that's actually able to help. There's also couches for them to sit around and a refrigerator so that they can store all of their food as well. Welcome to the Mechanical Prototyping Lab here at the center. We have a number of tools that are used by designers, medical professionals, and others that are trying to develop prototypes for their development projects. We found that the faster you can go from a concept that might be a sketch or something written on our walls to a physical prototype to begin getting feedback from stakeholders, the more efficient the overall process is. So we use this lab to make a number of quick and dirty prototypes. We have a milling machine, miter saw, bandsaw, lathe, and other tools that you might find in your garage at home. You'll notice that many of these tools are not super high precision tools, but rather they get the job done for building those prototypes. We employ an iterative prototyping approach that the sooner you can get something in your hands to look at how it works and use that to communicate the concept to others, the quicker you can get the feedback that's needed to move on to the next design. We also have some more specialty equipment in here. Behind me here, you'll see our Stratasys J750 PolyJet printer. This printer uses an array of nozzles that actually are able to jet out liquid that is then cured with an ultraviolet light. We use this to go from MRIs and CT scans to actual physical models that have the material properties and desired color that you would want. We can use this to do pre-surgical planning and many other things. This printer services the entire University of Minnesota and is a phenomenal resource tool. We also have a laser cutter. This is really great for developing two-dimensional or flat prototypes for testing equipment and other things. So across from the mechanical prototyping lab, we have our electronics lab. So here in our electronics lab, we have a small 3D printing station as well as 3 electronic workstations. These workstations have function generators, power supplies, oscilloscopes, multimeters, soldering supplies, and all the hand tools that we need to build the circuits and control systems that we put into our devices. Furthermore, we have a bunch of different donated pieces of equipment here. Zeus donates all of our catheter supplies that we need to build medical devices. Kind of moving along, we have 4 workstations set up that have all the modeling and software that we need to do 3D printing, as well as anatomical segmentation to prepare models to be 3D printed. Off to the left here, we have a number of on-hand supplies for building circuits, so things like resistors, capacitors, inductors, and all of that kind of stuff. So we don't want to get held up on the development of a device because we're lacking a single component. We also have some other supplies like a sewing machine, a hot wire foam cutter, and kind of some random odds and ends that we've collected from different projects over the years. As we keep going around the lab, we have an adhesive station. Loctite is a local adhesive company, and they donate all of the supplies that we use here at the center. And so this allows us to have basically any adhesive, whether it goes inside the body or is used outside of the body, on hand to build prototypes. Furthermore, we have a number of 3D printers here. I think we have nearly 20 FDM 3D printers. We use these to create prototypes and build models to get feedback very quickly. All of the PLA that is used for these printers is donated by NatureWorks. On my right here, you'll see our medical device library. Right here is about 10% of the devices that we actually have on hand in the center. We use these devices to compare how solutions that we might be developing compare to the existing solutions, and we also use these actually as prototyping supplies. So we allow everyone to take these devices apart, look at how they work, and then repurpose them into new devices that can hopefully get to the marketplace in the future. Furthermore, we have a number of prototyping supplies that are available for anyone using the center underneath. The other 90% of the devices that we have are in storage and inventoried, so you can search for the device that you might want and then be able to go ahead and go grab that. This is a really valuable tool and is being used all the time. We actually obtain most of these devices from our friends in industry that we collaborate with under sponsored research projects, as well as the hospital here on campus. Off to my left here, we have a number of storage lockers that can be used for teams to store their things, as well as storing 3D prints. As we continue to do more anatomical modeling, we now have to be concerned with HIPAA. So when we 3D print real patient-specific anatomy, we need to have a place to store it. So students, researchers, and medical professionals are able to check out our locker key and then use this for the storage for the duration of their project. Behind me here, you'll see our patent wall. We may have picked the wrong wall as we continue to get more patents, but there's lots more room to hang them up. These patents have come out of the Innovation Fellows Program and a number of other programs here at the University's Medical Devices Center. This is the Medical Devices Center's virtual prototyping lab. This lab was started as a joint effort between Professor Erdman's research group in mechanical engineering here at the University of Minnesota and Dan Keefe's interactive visualization lab here at the University of Minnesota. All of the virtual reality systems that we have here were developed here, and the one that we're looking at here is actually the coffee table. We call it the coffee table because the student that did all of the software development, his name was Dane Coffey, who's now at Disney as an Imagineer. Our virtual reality systems have 3 main goals. The first one is to be able to design medical devices in real patient anatomy. So being able to actually cater the design of a device specific to patient-specific anatomy. We're able to take CT scans and MRIs and convert those into files that we're actually able to zoom through in a completely virtual environment. So thinking about a patient coming in, doing an MRI, and then going home, a team of physicians, doctors, or engineers could actually sit down and then navigate through that person's anatomy. The second objective of this is to do surgical planning. So if we have access to the actual anatomy of each individual, we can then determine where incisions might be made and make a number of different important decisions relating to that surgery. The third objective is actually to do practice surgery. So there are a number of procedures that the way that surgeons learn how to do these procedures is basically by going ahead and just doing it the first time. There's no reason that we couldn't put on haptic feedback sensors and have them go through a practice surgery before we do that. The main benefit of this system and these systems in this room are not actually to be able to just visualize patient anatomy, but also do simulation. So for example, we could use finite element analysis to look at the arterial wall forces after putting in a stent or something like that. Furthermore, we could look at the pressure drop in a piece of vasculature due to the presence of that using computational fluid dynamics. We also have a number of other tools in the center, in the virtual reality room here. We have the Z-Space system, which is a very small virtual reality system that's portable. It allows us to do many of the same things that we can do on the other VR systems. We also have a 3D scanner. So this is our copy and paste button for things. We're actually able to take an object, scan it, and then we can modify that object and then go ahead and 3D print it. This allows us to get something in our hands as we're working on prototyping. We also have a 4-monitor system here that we use to do a number of different simulations. The long-term objective is to be able to set up a system where we're actually able to communicate with physicians that may be in third world countries or other developing nations where there may only be one physician per 100,000 people. So that way we can use our tools that we have here to make more of a global impact. This room is always changing and always in development, but it is a wonderful resource here at the center. This is one of our biosafety labs. We have these labs to allow us to do tissue experiments and chemistry experiments. We have basic lab equipment, glassware, and other things that might be used in these types of experiments. This is the Medical Devices Center's brainstorming room. We pride ourselves with our ability to brainstorm ways to solve complex problems with innovative solutions. As you can see, all the walls are actually write and erase. We can also put posters up and different things that we can write on as we're coming up with different ideas. There's 2 projectors in this room so that we're able to have presentations with nearly 60 people present. Furthermore, we can actually close an acoustic partition so that we're able to separate the room into 2 parts.